Hello, my name is Krista, and today I decided to do a lecture in complex number. I have here one problem that z is equal to 1 plus 2i. So now I have a lot of questions here. We have 7 questions. So first we should identify what is the real z and what is the imaginary z of this complex number. Okay, so when you look here, this equation, the 1 is the real number. So we can write this here, R A. Sorry, so Z is equal 1, okay, and E M Z is equal to I. Okay, also we have the real part and imaginary part. Okay, and that's coming here. Right, now we should draw the Argand diagram. So you can do that by hand, but I prefer to do that by the GeoGebra, which is very good program and is very nice layout. And let me put here this equation. I'm writing z, and after that I put 1 is equal 1 plus 2i. And just I'm hit enter, and now I have this point here. When I have this point here, now I should go here. You see that this is the complex number. So now I will sketch one vector. I'm taking from the 0 here and to z. Okay, so now let me do this vector a little bit so we can see that. Let's take the object properties. And now we should go to the style. Let me see how it should look like this. So maybe it's enough. Okay. Okay, we say that it's good now. Okay. And so now I'd like to see this one. I'd like to see the number here. So I go to the object properties and then go here to the basics and then take the name and value and say, so now I get this. Oops, this one should go, I should delete. So, okay, so now I'd like to do the object properties even for them, for this Z. I'm going here and to take name and value. So now I have received this equation here. Okay, good. So now I think that this the letter is very small, so I'd like to do much more bigger. So I go to the option and take a font size. I will take maybe 32. Let me see how much is. Yes, it's good. Okay. So you see that here is the 1, but I like to change that in polar coordinates so I can have this length, which is here you see the 2,24, which is the square root of 5. And this angle here is 63,43 degree. And then now I will take one perpendicular line. So I'm hit first here, and I'm hit the x-axis, so I get this perpendicular line, which is here in the 19 degree. And I should put one point here, B. Okay. So now, okay, Control C. So I'd like to be, okay. So now, let us find this angle here. I hit here the angle. After that, I hit the B, A, and the Z, and I receive this angle here, which is a 63,43 degree. Let me take here object properties. Can I see if I can change? Advanced not here. Okay, I cannot change this. I'd like to change this angle to theta, but I cannot find now. It doesn't matter. Okay, so okay, we should use alpha, but let me do that a little bit more bigger so we can see this. So like this. So now we have everything okay. So, okay. And let me put one polygon here. Let me see if I can do that. I don't know. So, it's good. And the B, B is the same like this here. And the A, I'm sorry. No. Let me do again. So, and so. Okay. So B, I don't like to see B. But this coordinate here is 2. This is a 2i. And this coordinate here is G, is 1. It is this one. But I don't like to see them. Just I'd like to get this triangle so I can explain when I'm coming back to the calculation. Okay? So now, let me change the axis here. I'd like to change the axis. First we go here, and we take x-axis, and here we will write R, the real axis Z, and the imaginary axis here E, M, parenthesis Z. And I will change even this distance. Here we take 1. I will do that even distances for x-axis here, 1. So now we see the clear that everything is okay. So if you like to learn this program, you must working every day to be familiar with this program. I don't have so much time to do that, so but I have to do that. So okay, so now I'd like to hit print screen, and after that I will start the paint. Okay, it was not good. Let me see. No, it's not good. We will do it again. I take you one more time, print screen. After that, I hit this one here. Now will be good. I will start paint, Control V. And now I have these pictures here. So I will select. So I will put that in Word here to have something like that. I will crop this one, Control A, Control C. And now I will put this one somewhere here. That will be much more big. Season position. I will change that to 40 maybe. Okay. Let me see how big is. I will do again. I will take 30. Season position. 30. Okay. Is much better now. Hit this one here and I take the tide. Okay, this is good now. So let me put somewhere so we can see these pictures. So, okay. So this diagram here is the Argand diagram. So we have here Z, this is the one here. We have the length here, which is the square root of 5, and this is the square root of 5. And this alpha, the angle alpha, is the 63.43 degrees. So now we should calculate the absolute value of this length here, of this vector. So how can we do that? We can do that by hit the Z, and after that we should take the absolute value from this here, Control C. I'd like to be much more quicker. So, and this is equal square root from 1 squared 2 plus 2 squared 2, which is 1 squared 1 power 2 is 1, and 2 power 2 is the 4. 4 plus 1 is the square root of 5. And square root from 5 is nothing than 2.24 length. I'm sorry, length units. Okay, you understand what I mean. This is the length units. We don't know if this one is this millimeter, is the centimeter. We call that length units. Okay, so we have calculated this one. So now we will find the conjugate of Z, and the conjugate of Z, that's a conjugate of Z is the is the 1 plus 2y, and we must put 1 like this here, and this is the the same like 1 minus 2i. This plus will be changed to minus, and 2i will stand. So this is the conjugate. Okay, so we have a solved this one there. So now we're coming to the argument of z. Argument of z. Argument of z is the same like angle. And the angle, I mean this angle here. So how can we find this angle? We can find this angle by, say, that this angle is alpha is equal to arc tangent from, here we have 2, this 2 divided by 1, which will be just 2. And we can write, if you have a calculator, in your calculator you see that we have a tangent minus 1, and because we have a 2 divided by 1 is the 2, and this is equal, and we have a 63 dot 43, and we have here a degree. So I'm sorry, I have a 63. Okay, so now we have a find even this one here. Cancel here. What happened? Yes. So now, if you like to solve this one in Euler formula, we should do it like this: that z is the square root from 5 multiplied by h, and we have a I multiplied by we have a here 63 dot 43 degree, and this will be, I'm sorry, multiplied by pi, okay, by pi, I'm sorry, Control G pi, and after that we divided that by 180 degree, okay. I have a little problem with this color, so that's it. And when we solved this one, we were divided the 63,43 degree by 180 degree, we should have, let me copy this one, it's much easier. And here I will write here, this is the 0.35, I think. 0.35 and G pi. This is the Euler formula. Okay, so we have solved now. So now we will find the polar coordinate. And the polar coordinate is something like this. First, we have this one here. which is the square root from 5. And we have a cosine from this one here. Let me copy this one. It's much easier than to write all the time. So it's much easier. So plus I sine from this. And now this one here is the same. This one here is the same by square root divided by this one here. And this one here. Okay. Let me take this one. So now, if you put this in a calculator, you should get 1, approximately 1. But you must do a settings in your calculator in radians, not degree. This is very important. Even this one here is the same. And this one here is equal to 2i. I is this one, and this here gives us 2. So we've done. Let me change this one. This is the equal 1. So, friends, let me do a little better this one. No. Okay. So, I'm sorry for that. Is equal. So, this is the final solution. So now, if you take here one page, so we have solved this problem. So I hope that you like this video, but before I'm finished, I will put the next exercises will be, I will write here, next X is, I will say Z equal 1 plus I multiplied by square root of 3. Okay, so try to do that by own if you succeed. Remember, you don't need to work with GeoGebra, but it's nice. You can get a very beautiful layout, and you can control if you're doing that right. Okay, so I'd like to show one more thing. So now if I like to control this, that this is okay, I can go here to view in Wolfram Alpha. So Wolfram Alpha should show me now if I did right. So let me see if everything is okay now. I'm sorry, cancel. I should take this one here. So you see here, no, something is wrong. So Wolfram don't like to solve this one. Let me see, start my app here. I have an app here. Wolfram. Let cast 10, if I did right. So my computer is a little bit slow. I have written this one time here. Let me write here z is equal. So 1 plus 2i. Okay. I don't like this, so let me do that like this. Sometimes works, sometimes don't work. I don't know what's the problem. Okay. I'm sorry for that. Why I don't know what is the problem, but if I take this one here, 1 plus square root, for example, square root from 3, maybe can solve that to show everything here. I don't know, but I should do the next time. Okay, now they don't function. I'm sorry for that. Thank you very much. I hope that you liked this video. Have a nice time. If you like, go to my YouTube channel and subscribe. I will put a lot of exercises, and I'll be happy if these exercises help you. Thank you very much. Have a nice time, and good luck to you.